So number 11. South Coast Utilities makes the following monthly charges for residential. Is this your problem set or is this your homework?
This is homework.
Homework? Number 11? Okay, I thought it was problem set. South Coast Utilities makes the following monthly charges for residential electric services. Service charge is $4.50. So that's the service charge, $4.50. Energy charge for the first 800 kilowatt hours is 62 or 0.062 per kilowatt hour. So that means that if you use under 800 units of energy, you pay $0.062 per unit. I'm not even going to look at the units of kilowatt hour. It's going to take too much time to explain what that means. So this is if you use under 800. If you use beyond 800 units, everything over 800, it's less money. It is 0.055. This makes sense. Think about it logically. When you go to a store, if you buy in bulk, isn't it cheaper per item? Right? If you go to the store and you buy a granola bar, or a power bar, or a Cliff bar, or some sort of energy bar, or something like that, it's like $2 or $3 for one of those in the store, right? But if you go to a place like Costco, or a wholesale place, you buy a box of them, they come out to be like $1 each because you buy like 20 of them. So when you buy in bulk, it's cheaper. That's what this is saying. If a person uses energy, if they only use under 800 units of energy that month, they pay about 6 cents per unit of energy. But if you use a lot of energy, the rate is cheaper. It's around 5.5 cents for everything over the 800 units. Okay? The problem says, express the monthly charges, or charge C, in terms of the number n kilowatt hours, if we're between 0 and 800, if we're bigger than 800, and then draw a graph for between 0 and 1500. This is actually pretty simple. Okay, let's go through this process. The starting charge is what? No matter what, how much do you pay? $4.50. So what is that in my equation? The y-intercept. Okay, the y-intercept. So right away we know we're doing a cost function for the number of units, and we're going to have a plus 4.5 at the end. That's the automatic charge you're paying. But if you're using under 800 units, you pay only 6 cents per unit, or 0.062. So that's going to be my slope, because it's per unit. Look at the units. Per unit. It's going to be a slope whenever it's per. So it's 0.062 n. This is for under 800 units. Again, $4.50 no matter what, and 6 cents, or $0.062, okay, times the amount of units you use. This is when n is between 0 and 800. Okay, that was part A. Part B says, well, what happens if n goes greater than 800? Can somebody tell me how part B would look based on part A? Ida.
Like C n equals 0.055 plus 4.5 n plus 4.5.
Okay, now here's the tricky part. There's something we have to change here. It's not just n. If I use 2,000 units, whatever, I'm thinking of a phone bill. If I use 2,000 units of energy, how many of those units are over 800? If I use 2,000 units, bless you, how many are over 800? 1,200. How did you get that? You subtracted what? So you take away the first 800 no matter what. So if I use 5,000 units, I take away the first 800 units, and the remaining of them I pay for at this rate. If I use 1,000,000 units, I take away the first 800, and the remaining I pay for at this rate. So no matter what, I take away how many units? So instead of n, I should put n minus, and put that in parentheses. That's why this is a tricky problem, that part right there. Okay? And this is between, or n greater than 800. Greater than or equal to? I don't know which way it would be. Let me look. Just reading the problem. Yeah, because up to 800, so this one should look like this. Okay, these should be less than or equal to. Up to and including 800 is the first, and that's after. And then the last thing says draw a graph. Okay, draw a graph for C of n between 0 and 1500. So the problem is that this is going to be a piecewise graph, and let me explain what that means. Okay, Okay, it's going to look like this, and you don't have to draw this. I'm not going to hold you accountable on the test. I'll tell you right now. So 4.5 is like, let's say this is 5, right? So here's 4.5. So it's going to have some slope, but once you reach 800 units, the slope is going to decrease. Okay, that's all this is. So the slope initially is what value? Who can tell me based on the equations? What's the slope here?
0.055.
In the beginning,
Oh.
0.062. Again, between 0 and 800, so between 0 and 800, okay, in the beginning part, you pay more money, 6 cents per unit. But after that, you only pay 55 or 5.5 cents per unit, so it's a slower slope. This is called a piecewise function. You will learn about this in pre-calculus a lot. Okay, you'll do a lot with piecewise. In calculus, this is a huge topic when you look at little partitions along the way. You could have a function that then goes on to become like quadratic in nature. Okay, it depends on what you have. All right, let's continue. Let's go on to the next one now. All right, number 30 says the following. F is a linear function. We're told that f of 5 equals negative 5, and f of negative 25 is equal to negative 25. And the problem says find f of 2 and f of 50. What would you do? What would you do? You're given two scenarios. You're given two scenarios. But what are those scenarios? Tell me. You got to go one at a time. What does this really mean?
Oh, it just means 2 points. It's like 5 and negative 5.
Good. And this is?
Negative 25, 8.5.
Yeah.
Then,
What do you got? Keep going.
Okay. And so then you put that into your slope equation and you get something like 2/3.
You get something like 2/3. So change in y is going to be negative 25 minus negative 5. So that's going to give me just 20, or negative 20 rather. And then negative 25 minus 5 is going to be negative 30. So yes, David's right. 2/3 is our slope. So before we go any further, because the question was what are we going to do? We're going to find the equation of the line between these 2 points. Again, we're given f of 5 equals negative 5. So that means when you plug x in for 5, you get a y out of negative 5. When you plug x in for negative 25, you get a y out of negative 25. So we have 2 points, so we're going to find the equation of the line. So we have the slope there.
I have a question, but isn't 5 was
Is in what?
isn't 5 like the y is 5?
Again, it's f of x. Functions are represented by f of x. What has taken the place by 5? X has, hasn't it? F of x. Now it's f of 5. So 5 is x.
But then when we solve them, don't we make f of x the y? Like when it says like f of x equals something x plus something y.
Yeah, and this is, look, f of x, this is what this is negative 5. So this is y. This is f of x, and that's equal to negative 5. So negative 5 is indeed your y value. Ida, just remember input output. You plug in what goes in the parentheses, that's your x. What you get out is your y. Input, output, always. So let's continue. Our slope is 2/3. Slope is 2/3, so we've got f of x equals 2/3 x plus b. Let's find b. How do I find b?
Plug in 2 points.
Yeah, well, 1 point.
1 point.
2 coordinates. Okay, so, or 2 parts of the coordinate. So let's go ahead and take this one and plug it in. It makes more sense. The other one's larger. So let's say negative 5. Again, that's the y value. Equals 2/3 times positive 5 plus b. How would I solve this problem? What's the easy way to solve for b here? I don't want to do this math. It's messy. Yeah, multiply everything by 3. Okay, this gives me negative 15 equals 2 times 5 plus 3b. Again, when you multiply by 3, you need to remember to distribute it to every term. Okay, in the equation. So the 3 times negative 5 is negative 15. The 3 times 2/3. The 3's cancel, leaving behind 2 and a 5. 3b is 3b. So we end up getting a 10 here. Subtracting it, we're going to get negative 25 equals 3b.
what I got.
Yeah.
And it was just so messy.
You guys you need to get this out of your head. So if you have to write it down, do it. Numbers are messy. Numbers in math class sometimes seem easy, but in real life, numbers are never easy. You're never going to get like, oh, it's 4. No, it's 4.012 or 4.15 or 3.98. It's rare that you get integer values in real life. Go to the store. Buy items. Do you ever pay an integer value? It's rare. Usually it's $3.99 for this item. Or $2.99. Or, I mean, if sometimes it's like 2 for $1, it's 50 cents. Or like 2 for $6, it'd be $3 each. Why do they do that? Why do they do that? Sorry. Nobody? Really? Why is it not an integer value?
I mean, it's just a guess, maybe, because they think that people would just like, oh, take the $4. Like,
What do you mean?
your penny. Like, if it's like $3.
Oh, okay. That's one way. I didn't think about that. Sure.
I feel like someone told me when I was a kid that people do that, like $2.99, that kind of thing, so they think it's like $2.
Yeah,
but
it's
not.
perception.
Yeah.
It's like, oh, it's not $3, it's $2.99. Like, come buy this TV at our store, $7.99, $799. It's $800, But people hear the $7.99, it's different. When you get gas, you go to the pump. It says $3.50, right? But there's always something after the $3.50.
9/10.
Yeah, 9/10. So it's really not $3.50 a gallon. It's $3.509. So in the end, when you pay for a gallon $3.50, you're really paying $3.51 if you round it appropriately. So whenever you get a gallon of gas and there's a number, it's really a cent higher per gallon. And they put the 9/10 at the end. But think about that. Every 9/10 of a penny that they're adding on adds up after a long period of time. So gas stations make out on that 9/10 of a penny. There was like I forget what it was a while ago that somebody said, what if they removed that 9/10 of a cent? How much money they would lose on a daily basis? It's incredible because the amount of gas that is sold in the world. Okay, so they do that on purpose. So it doesn't look like a number that it really is. Okay, anyway, back to the problem. You got a messy answer, yes. Let's write down our function. So our function now becomes f of x, and it's still 2/3 x, but now we have b. And b is negative 8.3, so I will write it as a minus. And I'll put the repeating sign over it, because I know that 25/3 is 8 1/3. Okay, 8 1/3. And 1/3 is 3 repeating. So that's my function, but what did the problem ask for? What did the problem ask for? To find f of 2 and f of 50. So now that you have the function, and Ida, this goes back to your question before, if I want to find f of 2, what am I really doing? If I want to find what f of 2 is, what do I really need to do to this function?
Well, you put 2 equals, and then you write the equation.
F of 2.
F of 2
Good.
equals 2/3 x, or 2/3 2 minus 8.3.
And then we get a number for this. And that number that we get is the y coordinate. So we're plugging in 2 for x. By doing f of 2, we're saying let x equal 2, and then let's just plug in. Let x equal 2, plug in, and we'll get a y value out. Okay, we'll get a y value out. So this becomes 4/3, right? 4/3, which is really 1 1/3, minus negative 8 1/3, or minus 8 1/3. What are we going to get? Okay, so 2 comma negative 7. 2 comma negative 7. I'll leave the next part for you to do on your own. Okay? I'll record for a quick second so you can see the image later. Okay, so negative 3 plus 1 negative 3 plus c equals 1. Add the 3 over c equals 4. Let's go to the next one now. This coefficient here is equal to whatever's here, which is a 1. So 2b plus 5 equals 1. So we subtract the 5, giving us negative 4, divide by 2, giving us negative 2. And then finally the last step, negative 2 plus 4d is equal to negative 6. So we add the 2 over, giving us negative 4, so d is negative 1. Okay? Again, the whole idea here is this. You need to group by exponent, or group by degree. So we grouped it at the beginning because the a had x cubed, and so did the negative 2. So it became a minus 2, and that goes next to the x cubed. And from that point on, you just equate coefficients. You look at both sides of the equation and set up these equations down here at the bottom based on setting the coefficients equal to one another.
So, like, A, B, and C aren't, like,
Variables, they're numbers. Yep, they're numbers. Okay?
That's the hard part.
Yeah, that's the hard
Set
one.
it equal to.
How do you know, like down here, what to do?
Yeah, like,
Okay, so see how this ax cubed minus 2x cubed became this?
yeah, but how do you get, like, how does it becomes equal to 0?
Because I look at the coefficients of this one. Let's go to the x squared. It's more obvious. Now go back. The coefficient here is this, right? Negative 3 plus c. And the coefficient here, what's the coefficient in front of this?
0. 1.
1. When there's nothing in front of something, there's a 1. That's all right. When there's not there, it's 0. So negative 3 plus c is equal to this 1 in the front. That's where this comes into play. Then I go to the next one. I see this linear term. See the 2b plus 5? Well, that equals whatever coefficient is here, which happens to be 1 again. So 2b plus 5 is 1 also. Then I go to the last part. This is the constant, right? There's no x here. It's the constant at the end. Negative 2 plus 4d equals whatever this constant is. So negative 2 plus 4d equals negative 6. That's where this equation comes in here. So what you're doing is you're simplifying the left-hand side of the equation to this up here, and then you're taking these coefficients and setting them equal to whatever coefficients are here. The x cubed happens to not be here, which is why we set a minus 2 equal to 0. Okay? All right, let's go to the next one. Okay? So 3.6. Problem solving using systems. So number 11. Oh, they're all problems. They're not, we're in exercises, so they're both problems. They're not number. They're both problems. Problem 11 and 13. Problem 11, a financial planner wants to invest $8,000. Some stocks earning 15% annually and the rest in bonds earning 6% annually. How much should be invested at each rate to return $930 annually? All right. So if we have two interest rates, it's like having two values like we did with quarters and nickels. That's all that is. So remember how nickels are worth 5 cents and quarters are worth 25? And you would do 0.05 times the amount of nickels plus 0.25 times the amount of quarters equals the total amount of money. It's the exact same setup for this problem. I can go through the quick little equations, but you guys can solve on your own. So they want to invest $8,000. So some of it earns 15%. Let's write down these numbers so we don't have to keep looking back. Some of it earns 6%. What are these as decimals?
0.15, 0.06.
So this is just like the problem with money. Okay? Now we'll say that X is the amount invested at 15%, and we'll call Y the amount invested at 6%. And the person is investing $8,000 total. Okay, so X plus Y is $8,000. So I've got $8,000 to invest. I can invest $6,000 here and $2,000 here. I can invest $5,000 here and $3,000 here. I can invest all $8,000 here and invest none of it over here. Okay, so it depends on what you're investing in. So together, though, the amount of investments I make in money is $8,000. And the person wants to have an annual return rate of $930. So they want to make $930. So all we need to do is go ahead and use our percentages now. Okay, and these are our two equations, and I'll leave it to you guys to solve that. I would recommend multiplying the second equation by 100 to get rid of those decimals, or just going right to a matrix. Okay? On your test, by the way, and I'm going to pause and go over this now. Sorry for the last few questions, guys. There's only so much time, so you can hear this. For your test.
I have a question. So, and then would you do like systems or conclusions?
Yeah, exactly. So you can use any method. You can use substitution, elimination, or matrix. On your test, I want to give you a quick format and then talk about the fact that some of the problems I'm giving you choices as to what you can use. To give you format problems or an idea, you're going to have 4 multiple choice problems. Around 10 or so of the like middle kind of problems, not word problems, about 10 or so of those problems in the middle of the test. I guess I call them short answer, but some of them are graphing. Okay? And then for your word problems, I'm giving you 3 you have to choose 2 out of. And then I'm giving you another 2, and you have to choose 1 out of those 2. Again, 3, choose 2, 2, choose 1. On the test, I specifically wrote for some of the problems that you're welcome to use a matrix to solve. But you need to show the systems of equations before you go into the matrix. For example, here, for this problem, this is enough information by word. If you want to use the matrix from this point on, that's fine. But I specified that in the problem. Is that clear? So for these last 3 word problems I wrote, use let statements in all problems. And once you set up your equations, you may use a matrix to solve quickly. On the test earlier, you're going to have to do problems by substitution. You're going to have to do some problems by elimination. And I specify that. If you don't use the method specified, you will not get credit. Because if you can do substitution 5 times, that's great, but you're not proving that you can do elimination. Is that clear? So you need to follow the directions. They are very specific. You need to use algebraic solutions on all word problems. I'm getting to the point where now you've taken 3 tests. If you stop using algebraic solutions, I'm not going to give you credit. You can't sit there and use guess and check. I'm sorry, the days are over of guess and check. You're in an honors class. Soon you're going to realize that you cannot use guess and check in the real world. You need to learn algebraic methods. Because you would sit there for days on end guessing and checking for certain problems. So get rid of that in your mind and start thinking about algebraic. Your word problems, I'll give you some hints. Can I write these down? Hints for word problems. Remember the example we did with the wind speed and the jet stream? Okay, keep that one in mind. Obviously different examples, but the theme. Okay, they're all in videos, guys. They're all in videos. Because we're doing a class, they're recorded. We did an example with Mr. Howell's brothers going to Shake Shack getting burgers and fries and stuff. Remember that one? Okay, keep that one in mind. Let's see. Stuff with like cost, like coins and stuff, and a total amount of money. Okay, not necessarily the coins, but that idea. Those will be 3 word problems. You have to choose 2 out of those 3. Okay? Now, the last two examples are going to have to do with functions. So remember the one that we did a minute ago, where we had like f of 2 equals this, and f of 5 equals this, and Dave gave us the 2 coordinates. We found the slope and the y-intercept and all that. One of those for sure. But I'm going to ask you, what is the significance of the slope? What does it mean and stuff? And then the other problem will be the one, remember we did like the oil leaking out of a tank? You have to come up with a function and realize that the slope was the amount of oil that was leaking per hour, and that the y-intercept was the amount of oil in the tank in the beginning. One of those kinds of problems. So you'll choose one of those 2 at the end.
It was
Okay.
oil leaking
And then the other one was like one where we're just given f of 2 equals 7 and f of 3 equals 12. Come up with a function for it, come up with the slope, all that kind of stuff. Okay? You can choose one of those 2 at the end. Liam.
Will the function probably not be able to say
Yeah, that'll be a good example to look at. And we did one of those in our video actually in the notes. Okay, so you can look at the notes videos.
For the Shake Shack one, you have to use a matrix, right?
You don't have to, but it would take you 10, 20 minutes to solve a 3-system equation. Don't solve that by hand. I'm telling you now, I put in the directions, I recommend you use a matrix for all of these problems. For all 3 of those word problems where you need a matrix or you need the systems of equations, please use a matrix. Please use a matrix. Other types of problems you can expect. Domain, where you have to find the domain. If I give you a fractional one, like we had like 2 over x plus 7. That's the function. What is the domain of it? Let's see. Stuff we did yesterday where you have to simplify by adding or subtracting polynomials. That's a gimme. You should all get points for that. Your exponent rules. Okay, your exponent rules from yesterday. You need to know those. Remember when we shaded on the graph with linear inequalities? You have to shade the side of the line. You could expect one of those, 2 of those. One where you have to do it yourself, and one where I give you the graph and you have to tell me what it actually means. You can expect a system. Remember the ones where it was like 2 over u plus 4 over v equals 7, and you have to replace u or 1 over u with x. Okay, I'll give you a hint. It looks like this, where it's the stuff with over u and over v. We did that with your homework problem, and we went over it in class. Okay, so it's not in the video, that one. So you should really look over your notes for that one that you took for the homework problem. Remember the example we did with substitution method where you solve for x in terms of k, where there were like 3 variables in that problem? Definitely know that. You need to be able to graph on your calculator and find the intersection. Remember how we graph 2 lines and we use the calculate function to find the intersection? This is why I tell you to bring this in every day. And then evaluating functions like f of 2, or g of f of 2, or f of g of 2, stuff like that. Okay? We did an example of that in class and it was in your homework. Liam.
It's a big test, Mr. Howard.
It is.
Is it out of 20?
This one's out a total of 75. Thanks for it. Guys, don't forget prom sets. Prom sets, okay? When are they due for you guys? Tomorrow.